So that was all about squares. So now we are going to talk about another new concept, that is square roots. So this might be a new term for you right now. You might be thinking that what could be root in mathematics, because we have learned about roots of the plants. But how are roots of the plants related to squares? Well, here we are not going to talk about roots of the plants, but we are going to talk about a function which is an inverse function of squares. Okay, so let me take this example. Let's say that there is a park in your locality which is in the shape of a square, because we have been learning about squares since quite some time. So you have a park. The area of the park is 1600 meters square. That means the total region enclosed by the square is 1600 meters square. So you know the area this time. So now your friend asks you what is the length of each side of the park, because you do not know how long is each side of the park. So that's not known to you. So how will you find out the length of each side of the park? So all we know that area of a square is equal to side square. That is, whatever is the length of the side, square of that gives area. So 1600 is the area which is known to us. But what is the side? How will we find out the value of side? So this becomes difficult, because you really do not know what to do. You know that square of the side is equal to 1600, but how much exactly is the value of the side? How will you find that? So that is where we make use of square root. So here we are going to introduce you to inverse functions. Now this is not a new thing. You know this, you have learned about this, but it is just that we are making it more more official now. Let's say that this is you. Your father gave you 5 chocolates. Okay, so how many total chocolates do you have with you? You have 5 chocolates. Now your mother gave you 3 more chocolates. So how many chocolates do you have with you now? You already had 5 plus your mother gave you 3. So how many chocolates do you have in total? So you have 8 chocolates in all, right? So what is the operation that you did in order to find out the total number of chocolates? You did addition. You added the number of chocolates given by your father with the number of chocolates given by your mother, and that's how you counted the total number of chocolates that you have. So looking at this, what do we see? That if we want to get, so let's say that there are 2 numbers. Now let's focus only on the numbers. So if you want to get 8 from 5, so if I give you 5 and I tell you that you have to make these 5 toffees 8 toffees. How will you make the 5 toffees 8 toffees? By adding 3 more toffees. So when you want to get 8 from 5, you do addition, right? Now if I tell you that I give you 8 toffees and you have to make 5 toffees, that means I am giving you more number of toffees and you have to make it 5. So what do you need to do? To make 8 chocolates to 5 chocolates, you need to eat 3 of them, right? So basically what you are doing, you have to subtract 3 toffees from 8. Only then you would get 5 toffees. Correct? So what do you see? You see that addition and subtraction, they are inverse function. So if you want to get 8 from 5, you add 3. But if you want to get 5 from 8, you subtract 3. So you deal with the same number. You are still dealing with the number 3. But instead of adding, you are subtracting it. So that is why we say that addition and subtraction are inverse functions. So I hope you understood the concept of inverse functions. Let us take one more example. Let's say that 8 multiplied by 5 gives you 40. So if I tell you that I give you 8 chocolates, right, and you have to make them 40 by multiplying. So how will you multiply? Let's say that you have one box of chocolate which has, one box has 8 chocolates, right? So how many boxes will you need such that the total number of chocolates is 40? So basically you want 40 from 8. So what will you do to get 40 from 8? You multiply by 5. Now if I tell you that I give you 40 and you have to make it 8. So what will you do? How will you get 8 from 40? So this time also you deal with the same number 5, but instead of multiplying, you divide. So 8 multiplied by 5 gives you 40, which means that 40 divided by 5 gives you 8. So with this you get to know that multiplication and division are also inverse functions. Now on similar lines, let's talk about squares. Now when I tell you 2 square gives you 4. So that means if I want to get 4 from 2, what do? I square 2. So if I want to get 4 from 2 by squaring, then I square 2. Now if I tell you that I want to get 2 from 4, so I want 2 from 4. So what should I do to 4 such that I get 2? So this time you need a new operation, and that new operation is square root. So square root and squares are inverse functions. So basically when you say 2 square is equal to 4, that actually means that square root of 4 is equal to 2. So square root of any number is that number which when multiplied to itself gives you the other number. For example, if you say that square root of 100 is what? That means square root of 100 should be that number such that the number when multiplied to itself gives you 100. So what is that number? That number is 10, because if you multiply 10 with itself, that is 10 into 10, you get 100. So if I ask you what is the square root of 25, so you need one such number which when multiplied to itself gives you 25. So the answer would be 5, because 5 square is equal to 25. That is 5 multiplied to itself gives you 25. So this is square root. So I hope you understood what is square root. So square root is a new function for you. It is the inverse function of square. Okay, now why do we call this square root? That's because when you look at it very closely, okay, as I said, that roots are something which you could more easily relate to plants. The base, the parts which are present towards the base of the plant, they gives the strength to the plant, they support, they give mechanical support to the plant, right? So they are present in the lower part of the plant, or they are present in the base of the plant. So with that logic in mind, you can very easily see why these are named square roots. I mean, this is one way to, kind of prove that analogy. Like here in this case, 2 to the power 2 is 2 square. So here this 2 which is at the power, and the base 2 is this 2 is called the base. For example, if you say 3 square, here 3 is the base. If you say 4 square, so 4 is the base. Right? So whenever you write a square, the number which is at the bottom is the base, and this 2 is nothing but the power. So in square root, you would have seen that the value that we get is the base. So we are actually getting the value of the base using square root. For example, root over 25. The value of root over 25 is 5. So if you look at the square function, it is 5 square is equal to 25. So with this square root operation, you are actually finding out the value of the base. So that is why this is called root. So square root, because this is it. We have the term square because it is inverse function of square. Root because it gives you the value of the base. That is why it is called square root. So now let's look at square roots of different numbers. So till now, while we were discussing about squares of numbers, this is something that we were always referring to, like the squares of the first few numbers. Right? Now let us look at the square roots of these squares, because as I said, square roots are inverse function of square. So if I say 1 square is equal to 1, that actually means that square root of 1 is equal to 1. So here, I think the first example will not be a very good example to illustrate this. So let's move on to the next one. You see 2 square is equal to 4. So to get 4 from 2, we square 2. But to get 2 from 4, we find square root of 4. Similarly, to get 3 from 9, we square 3. But to get 3 from 9, we square root 9. So you see, they are just the inverse function. So if 4 square is 16, that means square root of 16 is equal to 4. And in a similar way, we can find out the square root of the first few perfect squares. Now, this next question that might strike your mind is, that means we can find square root only for perfect squares. Well, in a way, yes, when you say that the value of square root, if you say that the value of square root should be a whole number, in that case, yes, the square root value of perfect squares will only be whole numbers. Like square root of 25 would be 5. But if I ask you to find out the square root of 24, you cannot get one whole number, because 24 is not a perfect square. There is no such number which when multiplied to itself gives 24. So you cannot get root over 24's value as one whole number, even if you try to find it out. So for root over 35, you will not be able to get a whole number. So yes, when we are talking about the basics of square root, we will right now deal with the perfect squares. So then now next question that comes to your mind is, how do we find square root of a number? That it seems to be a big challenge, that finding squares were pretty easier because we only had to multiply, even if we go by the actual multiplication method, but then we learned some tricks also to make that easier. But how do we find square root? Now we have a couple of options. So first let us talk about the simplest option, which is repeated subtraction. Though it is the simplest option, but it is not a very favorable or very suitable one. But still, we will learn about it. Now if you remember, while we were learning about squares of numbers, we saw that to find square numbers, we added odd numbers. So I think this list would help you to go back to the recap. So you see, for all the perfect squares 1, 4, 9, 16, 25, 36 and so on, to find their values, we just kept on adding odd numbers, right? And then we said that the sum of first n odd numbers is n square, and that n square is a perfect square. So that was one way of finding squares of numbers. Now we saw that square root is just the inverse function of squares. So this time also we will do something with the odd numbers, but we will not add. Instead of addition, we will subtract them. So that is why this method is repeated subtraction method. So let us take one example. Let's say we consider the number 25. So you have to find out the square root of 25. So what are we going to do? We are going to subtract odd numbers from 25. And how are we going to do that? So we will do it in steps. So in first step, we subtract the first odd number from 25. The first odd number is 1. So how much do we get? We get 24. In the second step, we further subtract from 24, like from the result that we obtained in step 1, from that we subtract the next odd number, which is 3. So 24 minus 3 is 21. In third step, we subtract from 21 the next odd number, which is 5. So this becomes 16. In fourth step, we subtract from 16 the next odd number, which is 7. So we get 9. Now you might be thinking that how long are we going to do this? So we will continue this process until and unless we get a 0 here. So in step number 5, we are going to subtract the next odd number from 9, and the next odd number is also 9. So the result is 0. So what happens is, doesn't matter whichever the number is for which you want to find out the square root. So if that is a perfect square, only then you will get a whole number for the square root, right? So you will be able to find out the square root only for the perfect squares, right? So if it is a perfect square, then as you keep subtracting an odd number from that number, you finally would get 0. Now what you have to do? Now you have to see in how many steps did you get this 0. In how many steps? 1, 2, 3, 4, 5. So you got this in 5 steps. So that means square root of 25 is 5. It is as simple as that. Okay. Now you might be thinking, when we were doing squares, we were adding consecutive odd numbers, right? For example, to get 25, we added the first 5 odd numbers. So here also we did the same thing basically. We subtracted the first 5 odd numbers. So since it is subtraction, so we try to do this in 5 separate steps so that it becomes easy for you to see that how many times you did that subtraction. So you see, just the inverse thing. So since square root is inverse of square, so to find squares we added odd numbers. To get square root we subtract odd numbers. Perfect. However, this method is not suitable for large numbers. For example, here we took 25, so that was fine. Now let's say that if I ask you to find out the square root of 121. So do you think that this is a very suitable method? Because in that case, the square root of 121 is actually 11. So you are actually going to have some 11 steps like this. So if I ask you to find out square root of 1600, so you will have some 40 steps. So this number is not at all suitable for large numbers. So we need some other method. So